Welcome to a deep dive into a concept that just might turn your understanding of the universe upside down. We're tackling the idea that the universe isn't just running down. It's actually getting smarter, more complex, and it's all thanks to a process. We usually think of as disorder, entropy.
That's right. We're really diving deep into the idea that entropy, which is often seen as a force of decay, is actually a process of restructuring information towards greater density and complexity.
We've got some fascinating excerpts to guide us from information density, entropy and the self-organizing universe, and the universe, and evolution of information and consciousness. And these sources propose some pretty wild ideas. Things like black holes acting as cosmic processors, and life itself being an expression of this universal optimization.
It's a framework that really challenges our basic understanding of the second law of thermodynamics. You know, we're often taught that the universe inevitably descends into disorder. But what if entropy is less about disorder and more about a constant upgrade to the universe's informational software?
So maybe a little refresher on entropy might help here.
Isn't
entropy essentially a measure of how spread out energy is in a system? More spread out equals more entropy.
And traditionally, we've seen that as a movement towards disorder. But these sources suggest a different perspective. What if instead of just spreading out, energy is actually being restructured into more complex and information-rich states?
So it's not just about things falling apart. It's about them being reassembled in a more efficient and complex way.
Precisely. Think of it like this. When a tree dies and decomposes, it seems like disorder. But those nutrients fuel new life, creating something more complex from the building blocks of something old.
That's a great example. But those are biological processes. How does this apply to, say, stars and black holes? That's not exactly a tree decomposing in the forest.
That's where things get really mind-bending. Remember, the sources argue that information is not just an abstract concept. It's a physical entity that interacts with energy and entropy. And nowhere is that more apparent than in black holes.
So this is where I usually imagine black holes as giant cosmic vacuum cleaners sucking up everything in sight. You're saying they're more like processors.
Think of them as cosmic libraries. Storing vast amounts of information in a highly compressed form. The Beakenstein-Hawking entropy equation, a well-established concept in physics, suggests that the amount of information a black hole can hold is proportional to its surface area, not its volume.
Wait, so the information isn't lost inside the black hole. It's encoded on its surface.
That's the idea.
Wow.
It suggests that black holes don't destroy information, but they store it and potentially even process it. And this ties in with another key concept, Landauer's principle. This principle tells us that even erasing a simple bit of information requires energy, which means information is inextricably linked to the physical world.
So information isn't just some abstract thing floating around. It's woven into the very fabric of the universe. But if black holes are these massive information repositories, how does that connect to gravity?
Well, that's where things get truly fascinating. These sources suggest that gravity might not be just a force, but a gradient of information density in space-time. The universe essentially pulls things towards regions of higher information concentration.
So a black hole with all its densely packed information would be like the ultimate gravity well.
Exactly. And this leads to concepts like the holographic principle, which suggests that the information content of a volume of space is actually encoded on its surface.
That's a profound concept. Are you saying our reality is essentially...
Think of it like a 3D movie projected from a 2D film. The information is encoded on a surface, but we experience it as having depth. It challenges our perceptions of reality in a big way.
I'm definitely going to need a minute to process that.
Sure.
But before my brain completely melts, I have to ask, if all of this is happening on a cosmic scale,
right,
what does it mean for life here on Earth?
So before we were talking about information potentially being the underlying fabric of reality.
It definitely is.
Quite a shift.
Yeah, but if we zoom back in from black holes and holograms to life here on Earth, how does this idea of information density play out in something like evolution?
That's where we see this idea in action.
Okay.
Consider DNA, the blueprint of life.
Right.
It's the densest information storage system
Okay.
we know of in nature over billions of years.
Yeah.
DNA has evolved into increasingly complex forms, leading to the incredible diversity of life we see on our planet.
So instead of life struggling against entropy and inevitable decay, it's actually riding the wave of increasing information complexity.
Exactly.
Wow.
Life isn't defying entropy.
Okay.
It's evolving through it.
Yeah.
Life is constantly finding more intricate and efficient ways to store, process, and transmit information.
So we've gone from trees to black holes to DNA.
Yeah.
If this information density framework is accurate, what might it mean for the future of the universe?
That's where things get really speculative, but also incredibly exciting. The sources outline several potential phases of the universe's evolution based on this information density framework. One of the most intriguing is what they call the black hole intelligence era.
Okay, so this is where you tell me that black holes become conscious supercomputers.
Well, not quite conscious in the way we think about it. But the idea is that as black holes consume more and more information, they could eventually reach a point where they're capable of processing and manipulating that information in ways we can barely comprehend.
So the very objects we thought were cosmic dead ends could be the key to understanding the universe's future.
It's possible.
But what happens to the information they consume? Is it truly conserved? Or does it just vanish into the black hole's singularity?
That's a question that has puzzled physicists for decades. And the answer isn't entirely clear. Some theories suggest that information is indeed preserved. Perhaps encoded on the black hole's event horizon. You know, that boundary beyond which nothing can escape, not even light. Other theories propose that information might be radiated back out into the universe in a scrambled form through a process called Hawking radiation.
So either black holes are hoarding the universe's information or they're spitting it back out in a cosmic game of quantum telephone.
It's a possibility.
Okay, but how does the universe move from this black hole intelligence era to something even more complex?
The sources suggest that the universe might eventually reach a critical point of information density. Leading to what they call the universal feedback collapse. Imagine the universe hitting a cosmic reset button. Where the laws of physics as we know them are rewritten.
Wait, are you saying the laws of physics could change?
It is a pretty radical idea. But remember, this entire framework is based on the idea that the universe is constantly self-optimizing. What if, at some point, the current laws of physics become a limitation to further information processing and density?
So the universe decides it's time for a system upgrade. And what happens after this cosmic reset? Does existence as we know it just end?
Not necessarily. The sources propose that the universe could transition into a new informational cosmos. Time and matter, as we understand them, might cease to exist. Replaced by a reality where information is the fundamental building block, forming self-sustaining networks of unimaginable complexity.
My brain is officially an information overload. But let's bring this back down to Earth for a moment. What does any of this mean for us, for humanity right now? Are these just fascinating thought experiments? Or are there practical implications? Welcome back to our deep dive into a universe that might be a lot more complex, a lot more interesting than we ever imagined.
Yeah.
We've covered a lot of ground from black holes as cosmic processors to the potential for a universe driven by information. But in this final part, I want to focus on what it all means for us.
It's one thing to talk about theoretical physics and cosmic evolution.
Yeah.
But it's another to connect these concepts to our everyday lives.
Exactly.
So let's explore how this information density framework could potentially translate into real-world solutions and possibilities.
We've hinted at some pretty incredible advancements in energy space travel and even life extension. But how do we bridge the gap between these mind-blowing concepts and tangible actions?
I think the first step is a shift in perspective. We need to move beyond the idea that we are separate from the universe and embrace the notion that we are active participants in its evolution.
So it's not just about understanding the universe, but about realizing that we're shaping it in ways we might not even realize.
Precisely. And once we grasp that interconnectedness, we can start making choices that align with the universe's natural drive towards complexity and information density. It's about recognizing that we are not just observers, but active agents in the grand cosmic narrative.
I'm following you. But let's get specific.
Sure.
What are some practical examples of how we can align ourselves with this process? What could this look like in our daily lives?
Well, consider something as fundamental as education. We need to foster a new generation of thinkers who are comfortable grappling with these complex ideas about information, energy, and consciousness. We need to move beyond rote memorization and encourage critical thinking, problem solving, and interdisciplinary learning.
So instead of just teaching facts, we need to teach students how to think, how to connect the dots, and how to approach problems from multiple perspectives.
Imagine classrooms where students are exploring quantum information theory, experimenting with biomimicry to design sustainable systems, or even debating the philosophical implications of a conscious universe. We need to equip young minds with the tools to not just understand the universe, but to actively participate in its evolution.
That's an inspiring vision for education. But it's not just about schools, right? We need this kind of thinking to permeate every aspect.
Absolutely. We need to cultivate a culture of lifelong learning where curiosity and exploration are valued and encouraged. We need to create spaces where people feel empowered to ask bold questions, challenge assumptions, and explore unconventional ideas. This shift in thinking needs to extend beyond academia and into our communities, our businesses, and our government institutions.
I love that. It's about fostering a sense of wonder and a thirst for knowledge in everyone. But let's talk about the practical applications of these ideas. How can we translate this information density framework into tangible solutions for the challenges facing humanity? How do we move from theory to action?
That's where things get really exciting. Imagine a world where we view energy not as a scarce resource to be exploited, but as a fundamental expression of information flow. What if instead of burning fossil fuels, we could tap into the energy embedded within the fabric of space-time itself?
Wait, are you suggesting we could literally...
It might sound like science fiction, but it's not entirely out of the realm of possibility.
So you're saying it's possible?
If we can understand how information shakes energy at the most fundamental levels, we might unlock energy sources that are currently beyond our comprehension. Of course, this is still highly speculative, but it highlights the transformative potential of this framework.
That's incredible. But even if we're not quite ready to pull energy out of thin air, there must be more immediate applications that we can explore.
Consider the field of biomimicry, where we learn from nature's designs to create more efficient and sustainable technologies. We can look to nature's elegant solutions for inspiration in developing new forms of energy generation, transportation, and even architecture. The natural world is a masterclass in information optimization. And we have much to learn from its billions of years of evolutionary refinement.
That makes perfect sense. We've already seen amazing innovations inspired by nature.
Like solar panels modeled after leaves? Or wind turbines that mimic the wings of birds?
Exactly. And we're just scratching the surface of what's possible. Then there's the rapidly evolving field of quantum computing, which leverages the principles of quantum mechanics to perform calculations that are impossible for traditional computers. This technology has the potential to revolutionize everything. From drug discovery and material science to artificial intelligence and cryptography.
And speaking of artificial intelligence, I'm curious about how this information density framework might impact the development of AI. We often hear about AI as a potential threat, but could it also be a key?
It's a great question. And I think the answer is both yes and no.
Okay.
It all depends on how we approach AI development. If we simply focus on creating AI.
That's more powerful and efficient at processing data. Then yes, there are potential risks. But what if instead we focus on developing AI that understands and aligns with the principles of information optimization that we've been discussing? What? We create AI. There's not just about processing data, but about understanding and contributing to the universe's evolution of information.
That's a really interesting idea.
Yeah.
Instead of AI as a rival, we could view it as a partner, a collaborator in our quest to understand the cosmos.
Imagine AI that helps us design more efficient and sustainable energy systems, develop new medical treatments, that harness the body's natural healing processes, or even explore the vastness of space in ways we can't even imagine. The potential for collaboration between humans and AI is immense if we approach it with the right mindset and intentions.
This has been an incredibly thought-provoking conversation.
It has.
It's clear that this information density framework has the potential to revolutionize our understanding of the universe and our place within it. But it also raises a lot of questions about the future of humanity and the choices we make.
Absolutely. It's a framework that invites us to rethink our assumptions, to embrace complexity, and to approach the universe with a sense of wonder and possibility. And ultimately, it's up to us to decide how we will utilize this knowledge, how we will shape the future, and what role we will play in the ongoing evolution of the cosmos.
Well, listeners, that's our deep dive into the fascinating world of entropy information and a self-optimizing universe. I don't know about you, but I'm feeling both humbled and incredibly excited about the possibilities that lie ahead. We've explored some mind-bending concepts today. But one thing is clear. The universe is far more complex and wondrous than we ever imagined. And as we continue to learn and explore, who knows what other incredible discoveries await us. So keep those minds open, keep asking questions, and keep diving deep. Until next time, thanks for listening.